You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. And if you're joining us for Product Thursdays, this is where we get into the absolute weeds of systems design. We're really trying to look past the hype, past the investor decks, and focus on what large companies are actually building and using in production right now in 2026.
Exactly. And our mission today is really extraction. We've got some great material, and we want to pull out the core architectural lessons that you can actually apply.
Right.
We're talking load management, future stores, and then that whole AI data frontier. The goal is to give you the blueprint, help you avoid that technical debt down the road.
I love that. Preventing future debt. Okay, let's jump in. Section 1, the architect's playbook.
Let's do it.
This really tackles that eternal problem for any global platform. How do you stay fast and local for the user, but also ensure the data is consistent and trustworthy everywhere?
Consistency and load. Those are the two big ones. They're the major friction points. If you solve for those, you're most of the way there.
So, Vinted, the global marketplace, they have a fascinating look at this. Their core strategy is, well, it's brilliant in its simplicity.
It really is.
Centralize all your write operations. Just everything goes to a single primary region.
And that becomes your consistency anchor, your source of truth. You completely eliminate that Byzantine problem of coordinating writes across, continents.
But then, what about latency? If all your reads have to go all the way back to that primary region, your user experience is terrible, right? So what's the trade-off?
The trade-off is that they replicate read-optimized projections out to those edge regions.
Projections, not the entire database.
Exactly. Specialized data views. Things that are optimized just for fast local access, like a search index or user's feed.
So they are intentionally, and this is a big commitment, embracing eventual consistency for those local reads.
A huge architectural commitment.
Yeah.
And it means they had to make sure the events flowing through their system were idempotent.
Meaning you can process it 2-3 times and it won't corrupt the state.
Right. And also that the system can tolerate events arriving out of order. It forces a higher standard of discipline.
On the teams themselves.
Yes. It's not just a database team problem anymore. Each product team owns their own asynchronous projections. It's a very mature way to scale.
That's the key right there, the organizational standard of ownership.
Right.
Okay, so Vinted solved for what data to serve. What about how much load the system can take?
Oh, yes.
Which brings us to Uber. And moving beyond that brittle world of static rate limiting.
Static rate limiting is fine until suddenly it isn't. You set the threshold too low and starve capacity, or you set it too high and the whole service just collapses in a surge.
And Uber's solution, Cinnamon, this is where it gets really cool because it's not some proxy sitting in front of the database.
No, it's embedded. It's intelligent load management built right into the storage layer itself.
And why is embedding it there so critical?
Because it gets immediate visibility into the real pressure on the resources, active requests, thread pools, all of it. It uses what's called concurrency-based detection.
So it's tracking how many operations are truly concurrent.
Yes, and then it applies a very sophisticated mechanism, PID auto-tuning.
PID. That's a classic proportional integral derivative controller, isn't it?
Exactly. It's decades-old control theory, now being applied to cloud architecture.
Yeah.
It lets the system sense the stress and regulate the input dynamically. It's self-regulating.
And the results just prove that dynamic control wins. I mean, the numbers are staggering.
They really are.
80% higher throughput, something like 70% lower P99 latency.
And P99 is what really matters for user experience.
Absolutely. And a 93% drop in P-coroutines. It's just a perfect example of feedback loops outperforming static designs.
It is. Now, speaking of complex architectures, we have to touch on Lyft's feature store.
Yes, because for ML and AI, the quality and freshness of that feature data is, well, it's everything.
And they built a serious blended architecture to handle it. You have batch features, things that change maybe daily, and then you have real-time features.
Like a user's activity in the last 30 seconds? How do they stitch that all together?
It's layered. For batch, you've got Spark SQL and Hive for massive scale. For the online serving, DynamoDB is the primary store.
But DynamoDB isn't fast enough for every single inference request.
No. So they put Valky in front as a high-speed cache for that microsecond level access. And then they have OpenSearch to handle embeddings and vector similarity.
And what about the streaming part? For true real time?
For that, they're using Apache Flink, processing events from Kafka or Kinesis. So the features the model sees are literally seconds old.
What's really important there, though, is the evolution toward governance. They're using Astronomer for orchestration, data contracts.
Precisely. You need the organizational processes, the quality guarantees to back up that complex tool stack. You can't just throw tools at it.
That sets us up perfectly for our next section, the enduring engineering challenge. Because we've talked about these incredible architectures, but the fundamental problems don't really go away.
That is the central and maybe slightly depressing truth of our field. The data engineer's journey. It's the same eternal loop.
Right.
From early ETL tools like SSIS, through Hadoop, and now to the dbt, Iceberg, AI agents. The tools change, but the transformation loop doesn't.
You're still just integrating data, cleaning it, trying to make it make sense.
And it really highlights how we've lost focus on proper data modeling. We try to solve schema issues with new software, but at the end of the day, schema issues are people problems.
Communication failures, different naming conventions.
Lack of ownership. We've all been there, right? You spend 3 weeks on a new cloud tool and realize the root cause was a column someone named poorly back in 2008.
That emphasis on fundamentals is so critical. And if you ignore it, you just get this erosion of data trust. The data becomes fragile.
It's death by 1,000 paper cuts. It's not one big failure. It's all the small, persistent issues.
Like instrumentation drift, when a developer changes a tracking event just a little bit.
Exactly. Or bot traffic, ad blockers, misconfigurations, they all add up.
And what's the real-world impact of that?
We see organizations where analytics reporting is just way off from their operational systems. Like one reported 18% fewer signups in their analytics than in the actual backend database.
18%.
Think about that. That leads to bad decisions, delayed strategy, and you end up building AI models on a foundation of lies. If your training data is 18% wrong, your model is worthless.
That fragility is the perfect setup for our third section, securing the AI frontier. Because if our data is already shaky, putting an LLM on top of it means we have to be, well, paranoid.
Paranoia is the right word. When your sensitive data is fragmented across hybrid and multi-cloud environments, the old perimeter defense is gone. You had to start with zero-trust data access.
Which means you verify everything every single time you're using workload identities, metadata-driven policies.
For continuous fine-grained control. Yes.
And there's a real financial argument for it. Companies using zero-trust models are reporting, $1.76 million lower average breach costs?
It's not theoretical anymore. It's a cost-saving measure. And that security has to get even more granular for things like our RAG pipelines.
Retrieval augmented generation. When an LLM is pulling from external documents.
You can't use standard file permissions for that. You need relationship-based access control or rebasey.
Rebasey. So you're treating access as a graph of relationships. User A is in Team B. Team B can see document C.
Exactly. It's complex, but it's flexible. And we're seeing powerful open source tools like SpiceDB, based on Google's Zanzibar, being used for this.
And not just by startups. OpenAI is using SpiceDB to enforce policies over 37 billion documents.
37 billion. It's an astonishing number.
And that's what secures domain-specific knowledge for their 5 million ChatGPT connector users. It stops proprietary info from leaking out.
The security stakes are high. But, the accuracy stakes might be even higher for adoption, especially for the dream of text-to-SQL.
Ah, yes. Using natural language to do self-service analytics. The potential is huge, but you highlight in this paradox. 90% accuracy is 100% useless.
It really is. It all boils down to trust and money.
How so?
If an LLM hallucinates an answer or writes a bad SQL query, the user immediately loses trust. They'll just go back to asking a human analyst.
And the financial consequence.
A bad query can be incredibly inefficient. Imagine a full table scan on a petabyte-scale warehouse. You can literally bankrupt an analytics budget with one bad prompt.
Wow. And right now, even the big platforms like BigQuery don't really have the evaluation tools to solve this accuracy problem.
That's right. The capability is there, but the quality assurance isn't. So engineers are turning to specialized tools.
Like AutoRAG, which automatically tests and tunes your whole RAG pipeline to find the optimal setup.
It takes the guesswork out of it. And on the front end, for accessing the models, you have things like Yonu.
A single interface that intelligently routes your query to the best model for the job. ChatGPT, Claude, Gemini, you name it.
It solves that fragmentation problem. The whole space is maturing. It's shifting from can we generate something to can we trust it and control the cost.
Which brings us to our final section, this collision between infrastructure and data.
the observability stack war of 2026.
It really is a war. We're seeing infrastructure vendors moving so aggressively into observability, trying to control that telemetry data plane. Why now?
Because that data logs, metrics, traces, it's not just for debugging anymore. It's becoming critical for AI operations, for security analysis.
And the standard that's emerging seems to be open telemetry for ingest.
Combined with Apache Iceberg for an open portable storage layer. It's all driven by cost control and the need for these AI-driven investigations that proprietary systems just can't handle.
And we're seeing the market consolidation reflect that. Snowflake planning to acquire Observe.
The goal is clear. Consolidate everything. Observability, telemetry, model monitoring, inside their data cloud. Own that whole life cycle.
We're also seeing deep integrations, not just acquisitions, like Databricks and Palantir.
That's about data federation, governance, compute pushdown. And the key phrase there is without copying it.
Zero-copy data sharing.
It's becoming a non-negotiable architectural requirement. You eliminate the silos and you slash your storage costs.
Yeah.
It's all about who controls the operational data that feeds the next generation of business intelligence.
What a journey. I mean, if we look back, we've seen this tension, right, between dynamic control, like Uber Cinnamon, and that need for single source consistency from Vinted. And all this is happening on top of this fragile data infrastructure, that death by 1,000 paper cuts, while we're trying to build AI that demands 100% accuracy. It's why we spend time here on The Vocal Technologist focusing on these specifics.
And it raises a really important question, building on that whole idea of trust. We demand, and we should, 100% accuracy from the LLM layer, from that text-to-SQL output. But why do we tolerate underlying data infrastructure that has no operational guarantees?
You're talking about the specifications themselves?
Precisely. Take the Apache Iceberg REST catalog spec. It's great for semantic interoperability. The tools can talk to each other, but it completely omits operational guarantees.
So there are no defined SLAs for latency or throughput?
None.
So what does that mean for the person building on it?
It means the standard pushes all the burden, all the fragility onto the operators and the clients. The infrastructure is portable, yes, but its reliability is entirely up to you. So the question is, what does it mean to build these highly reliable, zero-tolerance AI systems on top of data infrastructure that is, by its very specification, operationally fragile?
That is a very provocative thought to end on. That's the challenge for every architect out there right now.
It is.
Thank you for walking us through all of this today. We will be back next time with another exploration to help you stay ahead.
Spoken Tech for your ears.